presentation. Our next presentation will be regarding the use of mining tailing for printing, 3D printing of housing. I would like to ask Mr. Ashish Mohite and Fernando de los Rios to come here to hold their presentation. Fernando? I'm Christoph. It's your turn. There's a microphone over there. Okay. And then there's the... Should we try?
All right. Thank you very much. Hello, everybody. My name is Fernando de los Rios, and I'm the co-founder and CEO of Hyperion Robotics. We are a company based in Finland where we are bringing automation and sustainability to the construction industry. So just a little correction. We are not 3D printing housing, but we are definitely the 3D printing space. And I'm going to talk to you today about how we are optimizing the construction process, but also how we are using different kinds of waste materials, such as mining tailings. So we, at Hyperion, we are formed by a team of experts from different countries. So we have 12 different nationalities from experience in robotics, automation, 3D printing, engineering. And we have partners such as KUKA and Peiko. And also we are working with some very big clients. So they are leading companies in different industries. Metso Autotech in the mining industry, Iberdrola in the energy sector, and also Techint in the industrial sector in Latin America. But our mission is to really transform this quite conservative, but also very big industry, which is construction, and bring sustainability and automation practices. And there are three big problems that we see that construction is currently facing. So one is the very low productivity. So construction is very inefficient. Processes have barely changed in decades, perhaps even centuries. Labor-intensive work, time-consuming, and also the second big problem is the fact that concrete is this massively used material, but it causes 8% of global CO2 emissions, right? And then finally, industrial waste and mining tailings. So there's huge generation of waste all over the world, and there's a big availability of materials that we can reuse and follow a circular process to make construction more sustainable. So our solution, how we are solving and tackling these problems, is with our 3D printing microfactories. Our microfactories are these mobile units that we can either have in a factory offsite or ship it from site to site. We can easily install them and start manufacturing. And we are selling these to our clients around the world. We follow a circular process. So we can either use a more traditional cement-based material, but also we have a big interest from our clients to use waste, for example, from mining, from the steel industry, from demolition waste. We can repurpose this waste, pass it through our microfactories, and produce more sustainable infrastructure products. This is our microfactory, so you can see the different components, certain existing technologies like the robotic systems that bring the high precision, but also with our own hardware and software, which are then provided to our clients. And here are some of the main benefits. So faster, cheaper, more cost-effective, safer, but also more sustainable, right? So if I want to, if we want to go a little bit more into detail, we have been able to show that we can reach up to 90% of less CO2. And this is because we can combine the recyclability of materials, design optimization, so we can use less materials, almost zero waste because of how precise is the process, and we don't need any molds. And then finally, because we need fewer trucks to ship less materials, right? Higher productivity due to automated process. We also have cost savings. We eliminate the need for molds, for form work, which is a big portion of costs, reduce personnel in the process, less overhead and logistics costs. Also higher quality structures, so the traditional process brings human error. This is something we are eliminating as well. High robotic precision and rigorous quality control. And then finally, last but not least, reduce health and safety risks, right? Less people in the process means less risk, and we have the robots doing all the hard and dirty work. I'm going to share with you a few use cases. Both you can see in the productivity side and also in the sustainability and circular side. So we have the optimized foundation with Iberdrola, one of the leading energy companies in the world, where we were able to come up with a solution where we could save 75% of materials compared to traditional pad foundations. So up to 80% less excavated soil, so we just put it back into the project. We follow a circular process. We use less cement, so the process is more sustainable. And then there's almost zero waste. And you can see here the process from the start of the production all the way. We started with Iberdrola doing the prototyping of this foundation, and then we shipped it to site. We did all the testing, and by doing the full-scale testing, we could prove that we could reach 3 times the safety factor. So our client was quite happy with the results. And in terms of code compliance, this is a great question that our clients are always asking. We follow a rigorous testing regime where as long as we can show that we reach the different properties and characteristics that are required by the code, then we can automatically comply. Perhaps the most related to the topic of today's talk is a geopolymer water tank. So this is super interesting because with one of our mining clients, we were able to take waste from one of the mines in Finland and come up with this water tank that has around 97% recycled, so almost fully recycled materials and no cement, so zero cement. And this 2 meter by 2 meter water tank was printed in only 90 minutes. So it's a quite an efficient product and process, and it's fully reinforced as well. So this is a structural element, and now it's been already installed by our client and used in their production process. Finally, on the use cases, there's another interesting point. So trenches that can be used for electrical systems, so underground systems for example, oil and gas, for electrical systems. This we did with Techint, one of the leading contractors in Latin America. And we're going to go to Mexico then to deliver the next phase of this project. We have talked about foundations, water tanks, trenches, but really the possibilities are quite huge. Even artificial reefs, that we put one of these in Germany last year in the Baltic Sea. Staircases, footbridges, of course, building components, and urban furniture. Again, the possibilities are endless almost. Another question is, can we reinforce our structures? Which I mentioned it already, but the answer is yes. So we are not just printing concrete, but we are printing reinforced concrete structures. And now there is a short video that I want to show that our friends from production are going to help us play now. All right, so finally, I just want to invite you to visit our booth, where we have a sample of one of our foundations that has been cut, so you can actually see the reinforcement inside. Visit our website and come reach out to us if you want to collaborate. Thank you very much.
Thanks a lot, Fernando, for this